Hi guys, today's class I would like to discuss mutual inductance. Mutual inductance is an interesting phenomenon. So it is the production of induced EMF in one coil due to change in the current in the another coil. So let's see the definition. So it is the phenomenon of production of induced EMF. So the production of induced EMF in one coil due to change in current in another coil. It means we need to have two coils. So here I can take this is the coil 1 and coil 2. So if there is a change in current in coil 1, so that change in current causes induced EMF in coil 2. So as I switching in coil 1, so here it is change in current. The change in current in coil 1 causes induced EMF. Induced EMF in coil 2. Since I am having here an option switch on or flipping the cell, so this action causes a change in the magnetic flux through the coil 2. So according to Faraday's laws of electromagnetic induction, so there is an induced EMF will set up in the another coil. So this phenomena is known as mutual inductance. Suppose if I take another source which is known as alternating current source. So in the alternating current, the current itself is changes with respect to time. So that's what we call as AC. So in alternating current, the direction of current itself changes periodically. So as a sine function, so the direction how it is changes, so the current direction also changes with respect to time. So when you can supply an alternating source to coil 1, so there is a change in the induced EMF, there is a change in the current in the coil 1. That change in current in coil 1 causes induced EMF in coil 2. So this phenomena is known as mutual inductance. Let's see some interesting phenomena about this mutual inductance. To make you understand much more about mutual inductance, so let's see this setup. So this setup is having as like what we discussed earlier. So let's say this is a coil 1. If you can pass current in coil 1, so here instead of coil 2, so an aluminum plate which is kept on the coil 1. If there is a change in current which is passes in coil 1, it's about 800 amperes and frequency 900 hertz of an alternating current. If an alternating current which is passing through coil 1, due to because of the electromagnetic induction, you can see the aluminum plate is risen up and it is floating in the air. So it is a very interesting phenomenon. Suppose here you can see, so an electric source, a bulb, which is kept in the air, now it is kept on the plate. So what could be the cause the bulb to glow? So it needs current. So how the current is coming? So the current is coming due to because of the induced EMF. So because of the change in current in coil 1, change in current in coil 1. So here the current is changing due to because of the alternating current AC. So there is an induced EMF. Induced EMF will set up in this aluminum plate. That induced EMF causes an induced current. Induced current. So here the phenomenon what we are discussing, that is same. That's called as mutual inductance. What the mutual inductance says, if there is a change in the current in one coil, that change in current induces EMF in another coil. So because of this mutual inductance, you can see in another coil the current is inducing, and because of the current the heating effect also comes. It's so awesome how the induced EMF will set up at here. So these all causes at here because of the Michael Faraday. So in the early cases, current causes magnetic field, and the Michael Faraday thought how a magnetic field causes current. This what we are showing, this is Faraday ring. So with the help of this ring, he did the experiment demonstration. He has taken as an iron ring. In that iron ring, so he coiled two insulated wires, and one wire is connected to a galvanometer and another wire is connected to a cell. If there is a current flowing in coil 1, that current induces an EMF in the coil 2. So this is take as coil 1 and this will become take as coil 2. If there is a change in current in coil 1, that causes an induced EMF in coil 2. So this phenomena is known as mutual inductance. So from the mutual inductance we can write that, so the magnetic flux which induces the magnetic flux linked with the coil 1 magnetic flux linked with the coil 1. So magnetic flux linked with the coil. Suppose you take that a secondary coil, so this is the coil 2 and this is coil 1. Magnetic flux linked with the coil 2 is directly proportional to current in the coil 1. Current in the coil 1. Sorry, I can flip the numbers. So the current which is flowing, so that we can take as a coil 1. So the induced magnetic flux we can take that coil 2. So from this expression we can write that flux pi is directly proportional to current I. From the Faraday's laws of electromagnetic induction, so we draw to this relation. So that is the magnetic flux linked to the coil 2 is directly proportional to current in the coil 1. Suppose if I draw a circuit, so this is a current which is connected to a switch. So let this call as a primary coil, and if I take closely a secondary coil which is having more number of turns, which is connected to a galvanometer. So this is secondary coil. if current in the primary coil, so this current is change in current, is directly proportional to magnetic flux which is linked in the secondary coil. So how much current will changes in the primary coil, so that much amount of induced EMF will be set up in the secondary coil. So we can write the expression flux phi is directly proportional to current I. So here we remove the proportionality and we can make it equal by replacing a constant, here capital M times I. So here capital M is a constant which is known as mutual inductance or coefficient of mutual inductance. Here M equal to coefficient of mutual inductance. Now when you can write the induced EMF expression, since we know that EMF E equal to negative of d pi by dt. Now if you can replace pi equal to capital M times I, so the induced EMF which is inducing in secondary coil EMF E equal to minus d by dt of M times I. Now if you can rewrite this expression, M is a constant, so EMF E equal to the negative of M times di by dt. Suppose if di by dt equal to 1, which means the rate of change of current is unity. The rate of change of current is unity, then EMF E equal to minus M. So the induced EMF in the secondary coil is equal to the negative of mutual inductance. So we know that the negative sign shows about that the induced EMF will opposes the original EMF which is generating in the primary coil. So the mutual inductance definition. So the mutual inductance, the MI, here MI is a shortcut which I am using for the mutual inductance. The mutual inductance of two coils is defined as, the induced EMF setup, in one coil when the current in the another coil, the current in the neighboring coil changes at the unit rate. So the mutual inductance of two coils is defined as the induced EMF which is set up in one coil. Yeah, mutual inductance is nothing but induced EMF. But how it is? The induced EMF which is set up in the one coil when the rate of change of current in the another coil which is equal to 1. So we know that the negative sign, so I am not talking about anything about the negative sign. The negative sign always opposes the original EMF. So from the above, if I can write that mutual inductance M equal to EMF upon di by dt. So if we can write its SI unit, EMF units are nothing but volt, 1 volt, and current units are nothing but 1 ampere, and time units are 1 second. So So if you can write this expression again, so volt, amperes and amperes inverse and second. Yeah, if you can do the reciprocal here, so it will becomes volt, ampere inverse and second, which is known as 1 Henry, which is denoted with the capital H as a symbolic form. So the mutual inductance SI unit. SI unit is Henry. So Henry is a US physicist which worked in the parallelly about the electromagnetic induction, while Faraday, who was working in the England, and the Henry was doing the same work in the US. So to give as an honor, so the mutual inductance units are given to Henry. So finally, the mutual inductance of two coils is said to be 1 Henry. The mutual inductance of two coils is said to be 1 Henry if the induced EMF of 1 volt is set up in one coil when the current in the neighboring coil is changes at the rate of 1 ampere per second. So here I define 1 Henry. How you define 1 Henry? 1 Henry. So 1 Henry is equal to if 1 volt of current which is induced in one coil when a 1 ampere of current passing in 1 second in the another coil. So that is the definition goes to 1 Henry. This is all about mutual inductance. So here you got the new formula, mutual inductance M equal to negative of I will write the EMF in terms of, I would say that EMF new formula, EMF E equal to negative of M times di by dt. Here M is a new constant which is known as mutual inductance. This mutual inductance is coming to action if there is a change in current in one coil that induces a change in current di by dt in one coil is induces EMF in the another coil. So as a relation we can write that EMF E equal to the negative of M times di by dt. So here M is known as mutual inductance, its SI unit is Henry.